Okay. So first thing I'm going to do is that maneuver. So we have e to the y dy equals 3t squared plus 1 dt. Right. That's the only thing that needed to be moved because everything else is the way I want it to be. I wanted the y's on the left, I want the t's on the right. Right, so I'm going to integrate both sides. Antiderivative of e to the y with respect to y is e to the y. T cubed plus t plus c. Right? So now what we have to do is try to get the y value all by itself. Now, it's in exponential form, so let's go ahead and put it in log form. Right? So in which case, we're looking at a log base e. I'll just write it all in its full glory here, at least the one time, because I don't think I've recently done it this way. I'm just kind of skip steps. So log base e, because you have a base e. And then, really, I mean, just kind of cutting out the fluff. Swap those two bad boys. All right. So when you're converting, I mean, I haven't talked about it in a while, and I know that I just kind of jump right to, well, it's clearly this in log form, and then some folks may not actually know why that's happening. But the little shortcut for going from exponential to log, if it's in this form, e to whatever, or so base to the power equals the result, then you're writing the log with that base, and then you just swap these two bad boys and you have it in log form. Right? It's a nifty little shortcut. All right. So log base e is the same as ln. And so we're looking for the natural log of t cubed plus t plus c equals y. I don't need to put the absolutes within the log because you didn't get the log through the integration process. You got it from a conversion from exponential form. All right? So we don't need to guarantee, at least until we start doing stuff to this, that it has to be positive. And in fact, just in theory, it would need to be positive just based off this relationship, right? Because you have a positive value being raised to a power, its result would have to be positive by definition, right? So it's implied in the process. I've mentioned this a few times throughout the year. If you put the absolute value brackets on it, you can never be wrong. So if you're going to make a mistake, if you're going to err on the side of caution, right, and just throw those absolute value brackets. You don't always need them, but when you do need them, you really need them, so throw them in there.
So putting absolute brackets will never be wrong?
You'll never be wrong, assuming it's contained within the log, right? Because I've had people just say, "Oh, just throw some absolute value brackets in there." I'm like, well, you got to use them appropriately, but yeah, as long as they're within the log, you'll be fine. Yeah. All right, anything else? 18. Good looking problem right there, number 18. All right, so dy dx. I'm going to write that as x to the 1/2 over y to the 1/2. Move some things around. Looking at y to the 1/2 dy equals x to the 1/2 dx. Integrate. So we're looking at 2/3 y to the 3/2 equals 2/3 x to the 3/2 plus c. All right. Now these solutions to differential equations become infinitely easier if you don't have that plus c to worry about. But we do, so we have, because if that plus c wasn't there, I'd divide everything by 2/3. I would raise both sides to the 2/3 power and call it a day. You'd have y equals x, and that would be the end of it. Of course, lots of situations would boil down to y equals x, and it would kind of question the need to have a concept like this at all. So what we need to do is get this in an appropriate form. Now, an appropriate form could be y equals, but it could also be a standard form for a particular conic, all right? So we have both x and y being raised to a power. All right, so this is a variation on a conic. It's not a classic conic section like a cone, or a cone. Well, it's a section of a cone. Like an ellipse or a parabola or something along those lines. But it has the same structure, right? And so we can treat it like one of them, right? So in which case we want to solve for the constant. Good news is I can at least get rid of the 2/3 because the c can absorb all that if I multiply both sides by 3/2. So y to the 3/2 minus x to the 3/2 would be equal to c. All right. If you want, like I said, you could solve it for y in terms of x and c, and there's nothing wrong with that, right? And you got to be prepared to go either way because you never know how a choice is going to be outlined, right? But this is obviously a lot cleaner than y equals c plus x to the 3/2 all to the 2/3 power. Yeah. That's pretty gross. Anything else?